For the next question you have, we are supposed to do increasing and decreasing intervals. So the first thing that we must do in order to find increasing and decreasing intervals is find the derivative. Once we have the derivative, we can find the critical points. Then we'll make the sign chart. After the sign chart, we will analyze our data to determine if our function is increasing or decreasing. First, we must take the derivative. Notice I have rewritten this just a little bit to make for an easier chain rule instead of applying the quotient rule and chain rule all in one problem. So first of all, let's label u equals 4 minus x squared. F of u equals u to the negative 1/2. And we're ready to take the derivative. So f prime of u is negative 1/2 u to the negative 3/2 times u prime. Now let's find u prime. U prime is negative 2x. So if I build this back together and put it back in terms of x, I have f prime of x equals u prime, so negative 2x, over 2 u, so 4 minus x squared, to the 3/2. But we notice that since there is a 2 in the numerator and denominator, I'm going to cancel those out. And this is our derivative. Now that I have the derivative, we are going to find the critical points. To find the critical points, we see where is the derivative equal to 0 and where is the derivative undefined. So my first situation, I'm going to have x equals 0 because that is where the derivative is equal to 0. The other situation is going to require a little bit of algebra. I'm going to take the denominator and set it equal to 0. So then here I like to consider difference of squares so that I don't forget one of my zeros. And I get 2 plus x, 2 minus x equals 0. So I actually got two critical points there. I have negative 2 and I have x is positive 2. Now in order for these to be critical points, we just must make sure that these values are part of the domain of our original function. If not, we cannot use these values. Let's consider the original function to make sure that these are actually critical points before we substitute into our sign chart. So first of all, if I substitute in 0, then I have the square root of 4 in the denominator, and since that's a real number, we are good to go with x is 0. However, if I substitute in negative 2 and positive 2 into this bottom part, into the denominator, then I'm going to see that I have the square root of 4 minus 4. Well, since we have 0 in the denominator, I cannot divide by 0, which means that these two pieces are actually not critical points of my function. The most important part to remember here is that when making a sign chart, we have to substitute it into a derivative. In this case, since we're talking about increasing and decreasing, I am substituting in the values for my sign chart into my first derivative. So we need to pick something that is less than 0. So I'm going to go with negative 1. And we're going to pick something that's greater than 0. So let's say positive 1. If I substitute negative 1 into this function, I have negative in the numerator, and in the denominator, 4 minus a negative squared. Okay, so we have 3, and then we're raising it to the 3/2, so that's positive. So negative divided by positive, we have is a negative number. Now let's substitute in 1. If I substitute 1 into the numerator, we have positive. If I substitute 1 into the denominator, again, I have 3 to the 3/2, which is a positive value. Positive divided by positive is positive. Now let's take a look at this sign chart to determine where the function is increasing and decreasing. So first I'm going to see this negative means that I am decreasing from negative infinity until 0. And then this positive in my sign chart tells me that I am increasing from 0 to infinity. However, we run into a small issue here because negative infinity to 0 includes part of the domain that's actually not listed there. If I consider the actual domain of this function, I notice the domain is from negative 2 to positive 2, because any values outside of this interval is going to cause a negative radical, which is going to mean that I have some imaginary numbers here. So what that means is that in this situation, we are going to actually have to change our increasing and decreasing intervals to reflect the original domain of this function. So instead of having negative infinity here, I must start with negative 2, because that's where my domain begins. Then for the increasing interval, notice since my domain stops at positive 2, my increasing domain will also stop at positive 2.